Hi, and welcome to today's PCB annual event. During this session, we will tell you more about Best Professional Premium DFM, which utilizes PCBFlow DFM, giving designers access to state-of-the-art DFM analysis capabilities fully integrated within their layout software. My name is Hassink, and I'm an application engineer within Innofor, a value-added reseller covering the Benelux and Scandinavian countries. Before we dive into the DFM element of Patch Professional, the product and functionality itself, I would like to highlight that it is just one part of the PCB design validation capabilities that Patch Professional Premium contains. Best practice design processes validate the digital twin, a model of your design, early and often to minimize respins and actually shorten the overall design cycle. This shift-left approach enables design engineers and layout designers to validate within their native environment, minimizing the bottleneck waiting for specialist reviews, and freeing the specialists to resolve the remaining critical issues. This presentation we will look at the new integrated technologies for analysis and verification deployed throughout the design process, including manufacturability. Increasing complexity can slow down the organization's ability to make the right decisions. Therefore, companies need to find a way to go faster despite the complexity that they work with. Simulation tools and processes that are based on an efficient modeling platform allow teams to go from CAD to simulation to results more quickly and efficiently. To truly gain an advantage from investments in modeling complexity, companies need to leverage accurate models to run experiments. An increase in complexity also means an increase in the degrees of freedom available for adjustments. Through a systematic and intelligent exploration of the design space, electronic companies start to gain tremendous value from the models. So investments in the design explorations are critical. Simulation and analysis tools need to provide an open and scalable environment that can help the design teams automate simulation processes so they can quickly explore performance and more design variants. It also helps make the simulation accessible to more than just the simulation experts. Shift left is defined as taking a task that traditionally is performed at the latest stage of the process and performing that task at the earlier stages. Shift left simulation moves simulation and analysis early in the design process. The goal is to resolve issues early before they become significant. In fact, shift left is less about problem detection and more about problem prevention. A shift left approach that moves simulation higher up the development workflow allows performance to be confirmed early and optimized. That increases confidence in the design, de-risking the development and providing an enabler for the first time right design. Waiting until a physical prototype is created to perform design validation is costly. According to a report by Lifecycle Insights, at the prototype stage, failed designs lead to missed project milestones, extra rounds of testing, and having to work long hours. Simulation and analysis must be an integral and continuous part of the product development process. But what does it really mean? Speed is of essence during the design phase. Engineers need to simulate, not only early, but often to keep in step with the speed of the design changes. By iterating rapidly, engineers can discount the less attractive ideas and innovate further. Once the design has been explored and identified as valuable, it can be successfully used through each product development phase. In the upper flow diagram, we see traditional processes that leave simulation and analysis for the prototype lab. Aside from the obvious cost and the time wasted at this stage, there's also no way to do root cause analysis on when a problem was created, or looking at options to resolve them. A major improvement would be to perform simulation and analysis right before prototype stage. This is where most of the analysis tools get a start because someone is trying to catch a problem that they are having in the prototype or full production. But this approach often requires tool and discipline specialists operating hard to use and non-integrated tools. Design processes that depend on specialists for verification are rather inefficient, since the specialists become a bottleneck, and their only option to speed up reviews is to reduce coverage on every design. In addition, specialists by nature focus on a narrow area, like signal or power integrity, thermal, EMI, or manufacturing. So to evaluate trade-offs, multiple specialists must be consulted. Over time, validation tools have shifted left earlier and earlier in the design process. The ideal best practice to validate a design right after an error could be made in the system definition, schematic, or layout stages. And the person running the validation is the author at that particular stage. So, for instance, the design engineer at the schematic stage or layout designer at the layout stage. To enable this process, the validation tools must be tightly integrated with the authoring environment and easy to use. Ideally, the digital twin model of the design is automatically created, which greatly simplifies the virtual prototype validation process. By the way, this approach shouldn't threaten the specialists deployed at the end of the design process. By enabling the design authors to do validation, the specialists are freed up to perform more complex, complete, and multi-physics analysis on only the toughest problems, not the whole design. This approach also shouldn't threaten design authors who see it as adding extra steps to the tools that they are currently using within the workflow, because the net result is a shortened design cycle with fewer respins, interrupts, and higher product quality. Over the rest of the presentation, I will review how this first-time right design process can help, with the focus on PathPro Premium DFM, a cloud-based solution designed to meet the design from manufacturing needs. Pets Professional Premium DFM is bringing together 4 powerful cloud solutions to enhance your PCB design. PodQuest Portal allows you to search for electronic components from a catalog of billions of parts, download pre-made ECAD library model content, and create custom symbols and footprints using wizard-based part builders. Supply Chain provides access to component sourcing data, including pricing, availability, compliance, and lifecycle data, such as component risk, supplier datasheets, and instant purchasing options. Connect is the cloud-based workspace that brings teams together where you can efficiently manage, share, and visualize PET's project data. And PCBFlow DFM, giving you access to the state-of-the-art DFM analysis fully integrated in the layout software. Projects that are saved in PETS Connect can undergo DFM analysis quickly and efficiently using DFM rule sets that have already been configured by manufacturers and industry leaders. Let's drill down into this new DFM offering and reiterate that PETS Professional has fully integrated PCBFlow DFM analysis directly within the layout authoring tool. With PETS Professional Premium DFM, you simply save your projects in Connect and run DFM directly within PETS Pro Layout. All you need to do is to select the DFM profile and the analysis run transparently, returning the results to the Hazard Explorer. There's no need for DFM setup, configuration, upgrade, or maintenance. No IT overhead, no extra storage space or computing power needed. The DFM engine runs on the Siemens Cloud, so you always are assured that you are accessing only the latest version and analysis algorithms. The DFM results are instantly available directly within the PETS Pro Layout Hazard Explorer, Cross-popping is automatically, so you can fix the issues as you review them. No need to learn a new tool. Everything you need is in your existing software. Your subscription includes 12 months of unlimited access to design for fabrication analysis, so you can achieve that shift-left DFM into your design workflow and test for manufacturability early and often. There are some complementary services that are only available when you log on to PCBFlow.com, which is done using the same credentials as you would use for Pads Connect. Networking allows you to review and compare between DFM profiles to make sure you select the best analysis for you. You can also seek out and connect with PCB manufacturers who may have reserved DFM profiles. To be able to access these, it requires a connection between you and them. Of course, you can create your own custom DFM profile on PCBFlow.com, which will then be available in Pads Professional Layout. And not to forget the Quick Price tool to get pricing estimates from qualified suppliers. So now let's take a quick tour of the tool itself.
First, I will show you that this particular Aspen PCB design project is uploaded and managed in Pads Professional Connect, the cloud-based workspace which you can bring teams together, where you can efficiently manage, share and visualize design data. Cross-popping is being able between schematic and layout. When having a component being selected, you can select the pins and see which particular nets are being associated to which particular pin. Connect is an essential component and requires to be able to use PCBFlow DFM. With Pads Professional Layout authoring tool, let's check in the Aspen project and let's see how easy it is to perform DFM analysis using PCBFlow on your design. First, let's have a quick look at the StackUp, as it plays an important role of passing intelligent data into the PCBFlow or Vala MPI engines. As you can see, the StackUp includes material and dielectric thickness and copper widths, along with technology types, pre-preg versus core. So there's nothing to do here but let the system use to assign the desired constraints rule set from the DFM profiles available within PCBFlow. Before we get started the analysis, we'll have a quick look at the ODB++ configuration window. For Pads DFM, the system makes use of the NPI DFM scheme, and here we could make configuration changes in what we want to include as part of the ODB++ output, which in turn can have an effect of the analysis. So now let's start the analysis using the analysis menu called Pads DFM, which will open the interface on the right. When selecting the load DFM, it triggers two things. First, it will automatically use the credentials to get connected with PCBFlow, and the second thing is trigger the available fabrication DFM profiles, which will be automatically loaded into Pads Professional DFM. DFM profiles are the set of DFM rules that are pre-configured by manufacturers and industry leaders and will be available both on PCBFlow and Pads Professional users. We will go ahead and select the profile provided by Siemens and start the analysis. When the analysis is done, I will show you that within Connect, the reports are getting uploaded there as well under the Files section. They are both available within the Imperial as well as metric units, so that you can collaborate on these with your whole team, even that these experts maybe not are having access to the Pads Professional authoring tools, like Pads Professional Layout. Now let's jump over and take a look at the results as you would like with any other PADS professional DSC check within the Hazard Explorer. From the Hazard Explorer you will see we have a tab dedicated to the PADS DFM results. Once we open the PADS DFM tab in the Hazard Explorer, we see the categorized in constraint categories being edge, solder, mechanical and quality. When we expand these constraint categories, you will notice the name of the classification set that was being used for the analysis. Those results are further broken up by subcategories such as signal layer checks or power ground checks, and then finally for each individual check such as a cat short, tooling hole to expose copper stubs, etc. When we open the DFM dialog as well, the layout will be able to read upon the hazard description, so he becomes aware of the impact of the violation and makes a decision to accept or fix this particular issue. I will show you here some examples. From the Hazard Explorer you will see the severity setting, the measured value, the limit value, which is the constraints value that was defined within the DFM classification rule set, the violation layers and both the elements and nets involved with that particular issue, and of course the standard columns associated with issue acceptance. Let's start from the top and start with the cut short. Once we select an issue, the system will automatically change the proper layer and zooms into that particular issue. We then can select it and correct the problem and move to the next one, being a tooling hole being exposed to copper. Fix that one and go to the next. The next are some stubs. From the nets dialog we can see that some are associated to the net ground, which may be acceptable for this particular design. The other ones are not, so let's delete these particular stubs from the design and give our acceptance for the others. This will mark the issue so that they can be hidden and will not get reported again for this particular design. Another one is a via to copper issue. As part of the fabrication process, copper features are slightly increased in size during the compensate for etching, which will slightly reduce the original design spacing. So let's increase the spacing a bit to solve this issue as well and move on to the next. Exposed, next one seems to be related to the same object. Same net spacing would introduce slivers. Slivers are the narrow strips of laminate generated by two copper features of the same net. A laminate sliver may cause material to detach during the photo imaging process in the fabrication. The floating piece can cause defects or shorts, which reduce yield. In the manufacturing classification set, this is set to a particular value, and therefore we want to correct this problem and move on to the next. I will show you some additional ones, speeding up the movie a bit. When done or partly done, we can save the design and rerun the analysis. Since with PADS Professional Premium you will have the unlimited access to design for fabrication analysis, so you can achieve that particular left shift of DFM into your design workflow and test manufacturing ability early and often. Notice the green numbers within the Hazard Explorer when the second DFM analyses are ready, increasing confidence in the design and providing an enabler for the first time right design.
Thank you, and please visit us at innofor.com. If you have any questions, comments, or require pricing or additional information, please get in contact with myself. You can reach me on b.hassink@innofor.com.